5, 4, 3, 2, 1. Silence.
Hello again. This is David D. Hilster. Every Saturday we're here, Saturday Science Chats. We got a great show for you today. Nick Percival will be talking about time, one of those concepts that we've been struggling with for hundreds of years, but he's got some great answers, I'm sure, some stimulating discussion. He's got a great presentation, but we are here, and we're supported by the John Chappell Natural Philosophy Society and Dissident Science Channel. Howdy, everybody. Again, this is David D. Hilster, and we got a great show for you today. And this is every Saturday at 10 a.m. on the Eastern Coast. Oh, you can't hear me? Can you hear me now? Thumbs up. Yes? No? Hello, somebody in the green room. Can you hear me? No, you can't hear me. No. You can. But people with thumbs down. Oh, you can hear. Okay. People are hearing. All righty. Oh, volume way up. Oh, let me try. How about this now, folks? Is this better? Okay. Listen, I really apologize, and that'll blow people away from this channel. But yeah, it was too quiet. I have adjusting the volume on my mic, and a lot of times I'm way too loud. So I apologize. Well, I mean, sorry about all that, folks. Stick around. I've got a good show. It's not easy going with this equipment. It's hard to do a sound check, and I need to do that ahead of time because a lot of people who don't have headphones, they hear it a lot differently. But again, let's get back to what we're here for today. Every Saturday we have our science chats, and today, as always, I want to thank all of you for joining in. For those people online and around the world who subscribe to our YouTube channels, etc. It's really important for people to be using their critical minds to really criticize mainstream science. It's something people don't do in mainstream science. They don't do it in the universities. They don't do it in mainstream media. And it's something we should do with everything all the time. We should never accept what we're told, and we should look at it ourselves, let it roll around in our head, and decide for our own selves. And that's what this is all about. But of course, it wouldn't happen without the support of everybody here and those people watching. So I want to thank everybody. And of course, our mission here is to be an organization that is a CNPS for those dissident science subscribers. The CNPS is an organization that, above all, promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious scientific work outside mainstream science. Of course, we say this every week, but of course, if this is the first time you've seen it, we want to make sure you understand what you're watching. To provide a forum for open debate on modern topics such as physics, cosmology, philosophy, and mathematics. To provide a forum for presenting serious papers and theories without fear of censorship, and to be run and controlled entirely by its members. So that's what we're all about, and you can participate by signing up on our website, naturalphilosophy.org. Consider becoming a member. Memberships are annual, and we have monthly memberships, and I want to thank those people who are monthly members. You can sign up and automatically make your contribution to our organization, which keeps this going. What you're watching right now is because of that. And participate in community discussions on our website, and also post news and happenings about us on social media, because it doesn't help if you're one of the old people in our organization like myself from 60s, 70s, and 80s. We are no longer typing things on typewriters and sending them out through snail mail. Not the way the world works. So you can, of course, visit our websites. Of course, I talked about the community website, naturalphilosophy.org, but we also have an online magazine called Science Woke, and you want to take a look at that. We've got lots of views of that because it has really great articles, just like a magazine, but it's an online magazine for critical thinkers. And you'll see who are the movers and shakers. A lot of the people you see here are on that. We're adding people every year. We add new people. And we also have a Wikipedia using the same software as Wikipedia. You can go to wiki.naturalphilosophy.org, and you can read about it. We have over 10,000 pages of people who work outside the mainstream. And of course, we have our university, which we're working on this year to come up with courses in natural philosophy. And of course, there are memberships and donations that keep us going. If you go to our website, you can click on under members, called paid membership or donate. There is a donate button for a one-time donation, or you can go to even membership.naturalphilosophy.org. If you go to that subdomain instead of www, you'll take you to the page, and you can do a monthly $5 all the way monthly $50, or yearly from $35 to $500 or more. And we do have people who are donated, our patrons, and I want to thank them each week because they do make significant contributions. Dr. Cynthia Whitney, our chief scientist, she makes a donation to our organization, and is the chief scientist, by the way. And Nick Percival, who'll be talking today, he is also a patron of ours who's helped us out, and we want to thank him. Duncan Shaw as well, an anonymous donor. I want to thank him. He knows who he is. And Robert D. Hilster, my father, also has made some donations, as well as Kurt Renshaw. And you too can donate, and it's all tax deductible. We are a not-for-profit, not a 501(c)(3). It's something like a 106. I don't remember. All that's on our website. You can take a look at it. And our activity on our website, I always go to see what's going on there. And you want to go to, that's naturalphilosophy.org. And we got John Linus here giving a new link to some information, paper about matter with gravity. and talks about their standing half-wave particles of light, et cetera, et cetera, et cetera. It's one of the things that you can enjoy. You go to the active members, registered members. If you are registered and active, if you put down any discussions that you may want to have with people, or any thoughts or any links or any papers that you think are really good, then you can post them on our, it's like a Facebook page. It's one of the things called Buddy Boss on on WordPress is our website platform, and we subscribe to Buddy Boss, which is a new thing, which is really great. So if you haven't looked at it and tried it out, it is a really fantastic platform. We do pay for it every year, and that's one of the reasons we need your support. It's very vital to our organization. And hey, I'm one of the members, so things happen once in a while. My dad and I have things, but my father and I are looking for volunteers to read our book before publishing. We are not looking for reviews or critiques. We're going to get lots of those, I'm sure. And we're looking for people who are truly interested in our model and giving us feedback on the clarity of our text, graphics, and concepts. If you're interested, please contact us. It's on the website. And it just so happened my dad has a new video out. All the members who have websites or YouTube channels, we put them up here. My dad puts them out pretty regularly. This one's really interesting. If you haven't looked at the constant, he calls them man-made constants. And he talks a lot about G this time. I actually learned a lot from my dad because he does a lot of good historical research. So you want to maybe check that out. I'm going to hit this button, and when I do this, it tries to play. So no, I go to the next one. And the coming bumper, what's coming on our channel before we get to our main topic of today? Well, let's see. Yes, sirree. We got those great people coming. We'll take a little closer look at it. Coming next week, we're going to be doing another series with Ray Gallucci on gravity. Ray Gallucci doesn't have his own theory, but he looks at different people's theories and puts them to the test, as we say. And we're going to be looking at the electric universe's solution to gravity, which is electrical, of course. So I'm sure we're going to get a lot of people there because the electric universe is very popular. Lots of people who like that model and paradigm. Then coming right after that, I haven't actually formalized the date. He may be finding out by watching this, but I'm just so busy. But I've slotted him on the 27th because he's been sending me lots of stuff. This is just super fast. And if you missed this was last week, you missed a lot. You really should take a look at it. Basically, the way I would put symmetry math, the way I describe it now that I've learned a lot more about it, it's a mathematics for physics, basically. And physics has no negative numbers. It's basically got moving mass, and that's what this is about. And he actually, if you apply this, for instance, to some things in quantum mechanics or special relativity, it falls apart. Why? Because they use the minus sign and they use all kinds of variables and things that don't translate into physicality. And when they don't translate physicality, then they don't work, and then the math blows up. And but we'll be talking about that, where he calls it broken symmetry math, which turns out to be BS math, which I don't think that was a how do you say, a coincidence. But anyways, you don't want to miss that. And if you did miss the symmetry, definitely check out our last week's video on the Dissident Science YouTube channel or on our CNPS YouTube channel. Either one of those. And of course, coming up also is our conversations in fundamental physics it says February 2021, but it's probably going to be March because February is already filled up, which is great. One of the things we've been wanting to do with the Saturday morning chats after taking over after Franklin had been doing it for so many great years was to try to line up more people. And now it seems like they're lining up a month in advance. So he's coming. And of course, we have Stephen Bryant, who jumps in here once in a while. I do see him in the chat. And I'll be talking with him, and he's going to be presenting and talking about his book, Disruptive, the Rewriting of Rules of Physics. I believe there's a review of his book on sciencewoke.org and the review of Disrupted, Demise of Relativity. So you can see that, in fact, what people are what this group is about. And of course, as Alexander Unser says, keep working on your passion. That is, if you really think the universe is electric, keep going for it. If you think the ether is real, go for it. Keep working on it, because in the end, everybody has a right to do what they want and think what they want, and for them to, you come up to what the way you think the universe works. And we're not the judge. And because I don't believe it, or someone else doesn't believe it, or they believe it, doesn't matter. Because in the end, what will end up mattering is history will judge us all and our work. So at least that's my opinion. So today we're going to be looking at a 50-year analysis of time in physics, and we'll play today's bumper. If I scripted this better, I probably would do these in different order. But you know, we all do this as a hobby and a love of serious hobby. But before we get to our guest today, this is Nick Percival. This is from his biography. You can read on. I think you can read it on even on our new website. Nick graduated from Harvard in 1964 with a degree in physics. Oh, I always thought people who we thought were crackpots didn't know mainstream anything. Well, that's not true. Nick has his degree from Harvard, which I've heard is a pretty darn good school, and his degree is physics. And that started a now 50-year, I think he put 45, but now I can up that. I think he'll agree with that. 50 years focus on the twin paradox, and for those who study unique view of the relationship between special relativity and the ether theory. Most MPA or CNPS members can relate to Nick's espousing his alternative views. Nick initially debated many individual professors who held standard views on how the net proper time difference accumulates in a twin paradox scenario. The problems encountered in those debates led Nick to define a new debate methodology. New debates are done entirely in terms of pairs of events and the proper time between those event pairs. The unique this technique is described in his website, twinparadox.net. In addition, Nick published 5 papers defining his views. Despite winning debates, little impact on physics community resulted. Really? But that's not true anymore. We're starting to make an impact, and that's why we're here. Nick's current focus is on the GPS. This is, I think, written a little bit of time ago. I'm going to tell him he's much further ahead, I'm sure, on this. Clearly shows the asymmetric clock retardation is the correct physics model rather than special relativity time dilation model. Oh my gosh, you mean it's not magic? So, okay, it's real physics. As an entrepreneur, Nick started several companies. Most recently, Nick started in the late 1990s, co-founded teacherweb.com with the goal of providing teachers education a super easy way to create and update webs for communicating with their students. I think that, yeah, so this was way ahead of its time for sure. Nick developed software as a sole developer and received the patent for the technology and enabled the ease of use for those not familiar with internet and computers. So yeah, he is familiar with all that. And I think, do I have one more? Yeah, of course. Yeah, I think I had one more before we ring him up. If you haven't checked out his YouTube channel, great graphics, by the way. Oh, geez, that's like, duh. Am I going to break my arm patting myself on the back? No, it's nice graphics, really. The Nick of Time, which is a really cool name. His subscribers are going up, by the way. I think since we've been talking about it, he's been showing up. Hey, people are interested. He's got a bunch of videos. It's really interesting. Some of his videos have thousands of views because he talks about some things that not many people talk about, like the atomic clock experiment on the atomic clock, etc. So you definitely want to go to Nick of Time, check it out, subscribe to his channel. Subscribing means the more subscribers you have, the more people view it, and that's supporting it. So remember to subscribe to all of the people who have YouTube channels who are critical thinkers, who are challenging mainstream. You don't even have to agree with them, but at least support them. I mean, we're all in the same boat. It's like being in our own country, and we got to support the idea of critical thinking. And if you want people to remember and know your stuff, then you want to then, of course, support other people. So without further ado, I'm going to bring in our guest of honor and our presenter today, Nick Percival. How are you, Nick?
Doing really well. Thank you.
Yeah, well, it seems like it started out no one could hear me, but I didn't see too many complaints, so I'm wondering if that was that they good. I don't have to listen to Dave ramble on. But tell me a little bit. I know maybe give us a real quick. Why did you get into this? Before we get into, we're going to have this presentation coming up very shortly. But one of the things I like to ask people who are not familiar with it, because we've got a lot of new people in our organization and on our channels. How did you get into this? How could a person from Harvard University with a degree in physics end up doing what you're doing now, which is not exactly agreeing with what the physicists at Harvard espound? Give us a little bit of background of how you got to become a critical thinker.
Okay. When I entered Harvard to get a degree in theoretical physics, my main assumption was that these professors who all had worldwide reputations, and two had already won the Nobel Prize, and two more would go on to win the Nobel Prize. My assumption was that everything they taught was the truth, at least as far as current technology could provide it. So eventually I got to listen to the course on special relativity. And without really thinking about it, when they said things like, according to special relativity's time dilation equation, a moving clock will slow down physically. Well, I knew that didn't make sense because the equation's symmetric. So at best, and within special relativity, it has to be just observed. So it wasn't as though I was critiquing it. I just, the way my mind worked, it didn't make sense. So I reinterpreted it. But anyways, I read a Life magazine article about the astronauts, and it said that the astronauts would actually return to the Earth a little bit younger than the people or their twins that were left behind here on Earth due to their motion during their space trip. So I chuckled at that and said, oh, these science illiterate journalists, they don't understand special relativity. And I took it to my professor and I said, you've got to write these people and straighten them out. And he said, no, that's what special relativity says. And my jaw dropped to the floor. And that was the start of my now 55-year study of time. 10 years has passed since I wrote that.
But what did you think?
Intro.
I'm just curious because it's really rare to get a person like yourself. I mean, you and Dr. Cynthia Whitney are very special in that sense because she got her degree in MIT in special relativity and immediately applied it to a Sagnac, a circular gyroscope, right? And immediately failed. What was your feeling? I mean, you got a degree in physics and these are professors and these people you admired. I mean, what went through your head emotionally, or did it matter, or you just drove by that without any? I mean, it's got to be somewhat shocking. She told me she was shocked. Were you shocked by that statement, or?
Yeah, my initial reaction was to go numb. As I said, symbolically, my jaw dropped to the floor. I just couldn't believe it. But then being, a very young person and very naive, like 4 years at Harvard, I had no hint that anyone in the entire world had disputed special relativity or anything else that I had talked. So naively, I thought, oh my goodness, I'm seeing something that no one else in the world is seeing, which was totally untrue.
Right.
And I said, I've got to tell the world. So that started me off on trying to fully understand the twin paradox. And I spent many years on that. And
Right.
I eventually learned that Herbert Dingle had made a big thing about it, and
Sure.
it was all written out. But they didn't even mention the twin paradox at Harvard. Some universities do it, but then they just dismiss it and say, if you're not naive enough to question this, you should ask your professor or something like that. They don't even gather into the details. In fact, Edwin Taylor, who was called Mr. Special Relativity, asked me and my friend who ran the Harvard cyclotron lab to review his book on space-time physics, and I gave him a lot of my input, but particularly I focused on the twin paradox. And when he came back, he responded to everything except the twin paradox. I said, why did he do that? And my colleague who ran the cyclotron said he never answers questions about the twin paradox. So it was very
Yeah,
interesting.
very peculiar, very peculiar.
So I became addicted. It was, if I hadn't shown the life article to my professor, then none of this would happen.
Wow.
Life is almost like quantum mechanics. It's unpredictable. One tiny thing can send you off on a totally different path, just totally different.
Yeah.
It's quite interesting.
Yeah. Okay, well, that's great. I'm glad they gave the background because there's, like I said, a lot of people who don't know who you are and where you're coming from. So let's take a look. I'm going to take you back down here. Did you want to say something before we put your presentation up here?
Well, let me just comment about the NPA and the CNPS because for decades, I was writing papers and thinking and getting deeper and deeper understanding, but it sort of reminded me of the question, if a tree falls in the wilderness, does it make a sound?
Right.
Well, yeah, it makes a sound, but no one hears it. And that's what dissidents like myself experienced. We were doing all this work, but we could be easily ignored. And then I joined the NPA, the predecessor to the CNPS, and two major benefits. One, I got exposed to a whole lot of different ideas, and my ideas could be tested and get feedback from it. Even if you get wrong feedback, it always helps you.
Oh, sure.
At the very least, in how to present it better.
Right.
And so it was a godsend.
Yeah. And then the NPA, I mean, the CNPS, I think you mentioned another part, which was you doing the videos. I mean, I pounded on you to do these videos. And tell us a little bit.
I'm not basically a good presenter, so I was sort of intimidated, but thanks to you pushing me, I started doing it, and it kind of became fun. And I also learned about all these wonderful tools like Windows Movie Maker and Audio Amplifier and OBS. And they really, it gives you a louder voice.
It does.
And you learn while doing it, like many people have said.
Sure. Okay, well, that's great to know because I got two octogenarians become YouTubers. I tell that to my daughter, and they just think that's the greatest. They just think my daughter goes around saying, "Yeah, my grandfather has a YouTube channel. He's got over 400 subscribers." They go, "What? How old is he? 83?" But anyways, thank you so much. And I'm going to take you down here, and we're going to. He has recorded this presentation, so we're going to run this here. We got a new feature here with StreamYard, the service that you're watching here, so it allows me to play directly from my computer. So this is the presentation for today. So we're going to let it run, and it runs about 43 minutes. Definitely worth it. And take your notes, folks, and ask questions because when we get back, I'm sure we're going to have a lot of questions. But this is Nick. And the 50 years, a 50-year analysis of time in physics.
For taking the time to come and listen to this talk, it's greatly appreciated. First, let me talk about the mode of listening to this talk, because I've learned through experiencing that if one is listening to a new idea, or indeed any idea that runs counter to your currently held strong belief system, it's very challenging. And for new ideas, don't mentally rebut every point and every sentence as it comes out of the presenter's mouth. I've had 50 years of experience debating the special relativity theory. The only answer I ever got was, you don't understand special relativity. So even if I, or others, many others, gave very clear, simple, logic arguments showing that special relativity leads to a flaw, or a second interpretation of special relativity doesn't match the empirical data, that's received by the special relativist as, oh, your conclusion is that special relativity is wrong, but my belief system is that special relativity is right, so there must be something wrong with your logic. QED. Let's avoid that. And instead, I ask that you suspend critical analysis until you fully understand the whole thesis. Okay, short intro to the presentation. It's mostly a shortened version of 2 videos at the end of my Nick of Time 34-part series on time that I think the last video was made in like 2018, and then I've gotten distracted, but I hope to get back to that topic. I've got some new ideas. And Professor Percival says, somewhat tongue-in-cheek, you can get a CNPS University course credit for this presentation, but to get a PhD, you need to see the whole series. And after listening, we can have a friendly debate. Hello, this is Nick of Time. Welcome to this, our 33rd video in our series on time in physics. As you can see, it's entitled A Surprise Ending, which we normally think of as something that the author puts at the end of a book or story to surprise his readers. Well, in this case, the surprise was on the author, namely me, as I came to a new view about time at the end of this series. So this video and the next video will talk about how time does not have physical reality. It's a construct that we invent in our minds, but there's no correspondence to time itself in physical reality. 50+ years ago, I started on a physics path. I went to special relativity to look to see how it handled time, but it just seemed to have circular logic and be a dead end. So I continued on my way. I came to general relativity, and interestingly enough, it seemed to have a completely different model of time. I continued on and worked with Ron Hatch, expert in GPS, and looked at all of the GPS empirical data on proper time. And it seemed to me that ultimately the path inexorably led to the view of time that I'm talking about today. And we'll now take a look at the last 2 years where I was doing a series of 30+ videos on time in physics.
Now, when I started the series almost 2 years ago, in that first talk, I said, I had a couple quotes here. I said that time, we're going to look at time not from a philosophical point of view, but from a pure physics point of view. And to do that, we need to build time on a rigorous construct. And that rigorous construct was proper time, which was a true physics construct with an operational definition, and it's observer independent. So 2 years later, I really hadn't been thinking about this philosopher's idea of time in quotes. I had just set it aside as being too vague and didn't seem like it was specific enough that one could build physics on it. But I've sort of taken another step since then, and I wasn't, through that 2 years, I wasn't thinking about the philosopher's idea of time, but maybe my subconscious was, because I came to the conclusion that, hey, proper time is all you need. The philosopher's idea of time seemed superfluous, and the idea didn't seem to have any existence in reality, and further, it was kind of misleading as to what the reality of time was. And actually, without thinking about time, a pure physics view of time occurred to me spontaneously very recently. So let's look at proper time again. Proper time is operationally defined as the time accumulated on a clock between two events where the clock is present. So there's no ambiguity. It's crystal clear exactly what you mean by proper time, and proper time is used throughout all of physics. A clock is driven by a process. So when you think about it, the units of proper time are really units of a process. Basic clock shows hours and seconds, but that's sort of a translation into a common language of time, but the clock is just representing the number of cycles or vibrations of a physical process. So proper time is very physical, it's absolute, and observer independent. Very well defined construct. Now we're going to talk a little bit about philosopher's time. I was most of the way through my 32 first talks when I got a call from a philosopher who was writing about time. And a physicist who knew him told him, gee, you better give Nick a call if you want to understand the physics of time. So we had a series of communications, and he pointed me to all of his favorite philosophers and their key writings, and I read them, and they seemed just like a bunch of words to me. That didn't translate to physics, and in fact didn't really translate to reality. So I just sort of put that aside. But to try and give you an idea of philosopher time, it says time, like space, has its own existence beyond clock time. For some, I got the feeling that they're kind of thinking that there's some universal clock outside, kind of outside the universe, and 10 ticks on the universal clock is the real measure of time, and it may equate to 3 ticks on a physical clock on Earth and some other number of ticks on a physical clock on Jupiter or whatever. But I came to the conclusion that philosopher's time, and when I write time with a capital T in quotes, that's my shorthand for philosopher's time. Save a little space in doing the presentation. So philosopher's time to me, is an academic abstraction of the concept of time. And as such, is a bit dangerous if you have it influence your thinking on physics. So I came to think of philosophical time as really being psychological time. Philosophical time it seems to represent time that we move through, or that flows along past us, or that we are swept along by a flow of time. But I think that's a purely psychological model that we create as infants, and it's a very natural model when we look around and we see all these things that move and whatnot, that it's not space, it's movement, it's time. So we continue to experience that way, and our language is built on, I think, the philosopher's construct of time, and probably one sentence in 10 will talk about time, and not necessarily in the context of proper time. But I contend that time is not part of physical reality, philosopher's time. But because we've experienced it all our lives as being that way, it's going to be tough to adjust our thinking to a new perspective on what is time. Let me expand on that. I claim it's not like a river that sweeps us along or flows by us, and the past, present, future do not all exist simultaneously. The past no longer exists. At best, it's just a partial history of processes that exist. We have history books that tell a story about what happened, but many of them slanted this way or that have nothing to do with what actually happened. In the Grand Canyon, there's lots of sediments that give kind of a partial history of the epics of geology, but that partial history is open to interpretation and misinterpretation, and it certainly is not the whole thing, and it's not, you can't step into the past by looking at it. Similarly, the future does not yet exist, so there's no sense of things flowing by or us flowing into the future. Okay, the psychological construct of time, I contend, adds nothing to our understanding of physical reality, which is what these talks are focusing on. Further, the psychological construct of time, philosopher's time, is misleading and quite dangerous.
Hence, based on what we just discussed about the past and the future not coexisting with the present, time should not even be represented by a line going from past to present to future. At best, time is a point representing the current moment, and a point has 0 dimensions. Further, I hope we'll see later on that in reality, time does not exist at all, except in our minds. And hence, it's not even a point.
The philosopher's time, I'm saying, should be replaced by looking at energy and processes. Rate should not be expressed in terms of time, but process rates, which are expressions of motion and cycles and vibrations which in turn are byproducts of energy. So I'm thinking of physical time as not being an entity unto itself, but a byproduct of energy. When I say that it's a property of processes, it's sort of like color. Color doesn't really exist as a physical entity. Matter emits a vibration of a particular frequency that's interpreted by our brains as being a color. And I'm saying time is somewhat similar to that. It can be manifested by vibrations which we interpret as time. So it has a physical reality, but it's not an entity unto itself. It's sort of a byproduct property of other physical entities. For example, 1 second, here's our unit of time, but what is it? It's really defined in terms of a specific process, a number of vibrations of a specific process. Now, as I mentioned before, not only is the construct of philosopher's time embedded in our brains and the way we think since infancy, but it's also totally embedded in our language, and I don't expect our language to change to be consistent with what I'm talking about here. For instance, we used to say, "Hey, honey, wait 1 second, I'll be with you." I don't expect people to say, "Hey, honey, just wait 9,192,631,770 cycles of the unperturbed ground state hyperfine transition frequency of cesium-133. For one thing, I think that takes about 30 seconds to say, and the other thing, it's kind of difficult to picture how long a delay it's going to be. Okay, let's expand on that about time expressed as processes. Actually, since ancient time, there's no way of expressing pure time. We always express things in terms of processes. Like the year, the month, the day, the hour are defined in terms, respectively, of the Earth's solar orbit, lunar orbit, Earth's revolution around its axis, and for the hour, a fraction thereof. So, in a way, we've always thought of time as processes. It's just that we've abstracted it, and in our language, the term second, hour, day, don't necessarily conjure up the process that gave rise to that particular word. Again, I contend time is not a separate entity. Physical time is a property of motion and physical processes. It's a byproduct of physical causes and physical effects. One example of that is physical energy causes physical motion. That's an effect. And when we see something moving, that conjures up the idea of time passing.
Since the idea of time as something real, that's part of physical reality, that idea is so strongly held, let's try a little exercise. Let's think of a 100% static universe. Let's say the universe is made up of inert blocks, totally static, no atoms or any movement, internal movement, no gravitational attraction between the blocks. So, one would have space, but no sense of time. Now, fill that universe with energy, which then causes motion with those inert blocks and change, then time seems to be added. We think we're seeing time unfolding, but what we're actually seeing is energy, and energy causing change within 3D space. So I had proper time as the replacement for psychological time. And as I said, proper time is based on clock time that's displayed to us in minutes, seconds, hours. But the physical processes that drive the readings that are displayed on a clock face or other clock display, those physical processes are what drive that reading. They're the primary mechanism. That's where the real physics is going on. And then the real physics of processes gets translated into the language of human psychological time. And the process length that underlies proper time, that represents the fundamental reality behind or underneath human time. So we're getting displayed human time, but that's because there's a translation of counting up, keeping track of processes and process length, translating it into human terms. What's really happening at the physical level is processes, and all of their cycles or all of their revolutions or whatever is the natural way to keep track of process. So time is a generalization. The concept of time was built on many different stable cyclic processes. We have the year based on the Earth's orbit, the day, lunar cycles, and today the second is defined in terms of a specific atomic process, the number of cycles that accumulate. All those different processes and their durations have been generalized into a concept of time. But that concept only exists in our head. It's not a single time property that's moving or flowing or whatever. The problem is that the connection between time that we think about and the processes that gave rise to the language of time and the concept of time are at best secondary in our mind, and in many cases the connection between the processes that gave rise to the definition of the language of time has been totally forgotten, or we just ignore them. We think just in terms of time. And that gives rise to some erroneous concepts, such as the intuitive concept that time is flowing by us from the future to the current moment and into the past. Concepts like duration, Hello? Oh, you loved part one. Great. Thank you. I'm in the middle of doing part two. Okay, thanks again. Yes, duration in the model of psychological time is an important property of what we think of in terms of time. And time has many other properties that we associate with time. Now, duration in this model that's just in our head and not directly describing physical reality, duration is described in and measured in the language of psychological time, namely seconds, minutes, hours, which incidentally all come, their definitions all come from physical processes, a variety of different physical processes. But this tends to be forgotten when we're just talking about duration in terms of psychological time. However, if we build a model that's directly referencing what's happening physically, then when we look at processes are the foundation of that model. And each process will have duration as a property of that process. And duration in that physical model will be measured in terms of the inherent characteristics or properties of that process. So, duration in the physical model is measured in terms of cycles or revolutions or steps in the process. So duration and all these other properties of time have their counterpoint in properties of processes, all except one, namely the psychological time abstract model that doesn't correlate to physical reality has time being a dimension unto itself, whereas in the direct physical model, where processes are the fundamental building blocks, the foundation, we don't have each process have its own dimension. That would be totally superfluous. Okay, let's look at an example. In psychological time, we might say something takes so many seconds. That's the language of psychological time. And it's a very useful language, and I'm not saying we need to get rid of psychological time. It has its place, like an ordinary casual conversation, or even it can make things simpler in even parts of physics, as long as we understand we don't need to add another dimension when building a physics model. Okay, but in contrast to the 1 second, we would say that the duration of the cesium atom vibration in its ground state hyperfine transition is cycles. So duration can be talked about as 1 second, but that's in the language of psychological time, whereas duration in process time, or process length, would be 9,192,631,770 cycles. And the same general analysis applies for all of the properties that we think of as properties of time, except having its own dimension. Let's look at the construct of rate. Most people tend to think of rate inherently implying time. If you look at what's actually happening physically, you'll see that rate compares a specific amount of one process length to another process length in standard terms. So let's analyze one example, miles per hour. 60 miles per hour compares the process length of the process of a car having traveled 60 miles to 1/24th of the process of one Earth rotation, alias 1 hour. Now we can look at it from another angle. Let's say that the wheels of the car have to turn 100 times to go 1 mile. So to go 60 miles, they'd have to turn 6,000 times. So if we measure the process not in terms of miles traveled, but in terms of the natural units, or a more natural unit of that process, namely number of times a wheel turns, we'd have 6,000 revolutions of the car's wheels occurring in 1/24th of the process of one Earth rotation. That equates to 60 miles per hour. Let's look at a very different process. Let's look at the rate of an old 78 record. So that's 78 revolutions of the record per minute. And since a minute is 1/60th of an hour, that means there are 78 revolutions of the record for every 1,440th revolution of the Earth. So, again, rate just compares one process length to another process length, which is usually cited in some standard term. Let's look at the construct of past, present, future. Again, most people automatically think of that as an inherent structure of time. Well, let's look under the generalization of the concept of time to see what's actually happening physically. And the only thing that's happening physically, every process has a sequence of states. So that's the model that really exists, a sequence of process states. The state that we see, the active state, corresponds to our mental model of time as the present. Active state corresponds to the present time. Similarly, prior states in a process's sequence corresponds to the past. The next states in the sequence correspond to the future. So, if we wanted, we could change the terminology from the past, present, future of time to moving from the prior states in the sequence to the active state to the next states in the sequence. However, what we do is we generalize all these very different process sequences as time unfolding, where it's really each process is unfolding in a sequence of states driven by energy. That's what physically exists, and only that. There is no evidence that there's some great machine that drives the entire universe forward second by second. No great energy force that's driving the universe forward second by second. Okay. I propose something. It needs to be testable to be good physics. Well, we can see if, let's say, special relativity's time dilation is a function of time, or is it a function of processes? What's changing? Is time expanding or processes slowing down? All right, the test would be, take a set of clocks. We're all using different physical processes to measure our psychological time, and change their speed and or gravitational potential. If it's time that exists, and it's time that's changing with time dilation, then all clocks should change in unison. However, we know the answer already, namely the amount of change, amount of slowing or whatever, and even the direction of change, whether something slows or speeds up, depends on the process. And I'll give one example here. If we take an atomic clock out in space, and we take, let's say, a hourglass, where you have sand running through the hourglass. We know from empirical evidence that as the gravitational potential decreases, as we move these two clocks to the surface of the Earth, the atomic clock will slow as a function of the gravitational potential decreasing. But the hourglass clock will speed up, and time will accumulate much more rapidly on that as we come closer to the Earth. That's because these clocks are not really measuring time, but they're measuring process rates, which are measured in terms of processes cycles, or processes revolutions, or whatever. So we really already know, if we think about it long enough, that time as a separate physical entity doesn't exist. And there's no such thing as time dilation. What we have are processes are affected by a number of things, such as their absolute velocity or their absolute gravitational potential. And also, we know that their GPS knows that they're affected by air pressure and temperature. So it's already been there's already some empirical evidence that the focus, if you want to talk about what's happening physically, the focus should be on the processes and not on some abstract concept like psychological time. Since many of us inside the critical thinking community do not have access to multi-billion-dollar particle accelerators staffed by 1,000 or satellites launched by NASA, we need to think in terms of low-cost experiments. Hence, I took 2 equally ripe bananas and put one in the freezer and one just outside the freezer. After 2 months, I examined the empirical results. I will leave it up to the viewer to interpret those results, namely that the banana inside the freezer had a slower decay rate than the one outside the freezer. So, viewer, do you contend that the slower decay rate in the freezer was due to 1, time going slower inside the freezer, or 2, the cold inside the freezer slowed the decay rate? If you choose to, I think you need to accept the corollary that psychological time is superfluous when looking at the physics of what's actually happening, and that one needs to focus on processes and their properties and the attendant causes, the physical causes that drive those processes, including process rates.
Why does trying to think about the physical reality of time matter? Well, I contend we need an accurate physical model. Otherwise, we're likely to go astray, even if we come up with the right numerical answers for certain physical effects. If we don't have an accurate physical model in mind, then that's certainly going to inhibit progress. And let me give an example. I think that special relativity's model of 4-dimensional space-time, with space and time morphing into each other, that's an example where the concept of philosophers' time as a physical dimension is very misleading and made it easier to go down the wrong path. There is an example of an academic abstraction that has no basis in reality, facilitating going down the wrong path in physics.
So, let me try and summarize. Physics, and especially relativity, incorporated psychological time into its models, which was fatally misleading. It had some other problems as well. So, if we look at it, we see that underneath the human concept of psychological time is proper time. Because proper time, while it's displayed in the language of human psychological time, it's measured as process length. And it's a very physical definition. And it really is based on what's happening physically. So proper time is an improvement over using a generalized concept of time, and even better if you're thinking at the theoretical level and building a model is to use process length, because that is what determines our measure of time. And I contend that process length view is all there is physically, and all that's needed in physics. I've gone from nick of time to nick of no time, and here's my new icon.
Thank you. Thank you. It even puts that. Sorry about that. That was extremely fascinating, blowing my mind many ways. But I like this comment here. Love the banana analogy. But thank you so much. That was super mind blowing. I want to ask you a general question because I sort of know this from you talking to me. What was it that you had mentioned that you had a sort of change in mind about the time, that you had done all these videos and you've thought about it for 50 years, yet you've had a revelation in very recently, right? Maybe give us is that first, is that true? And if it is, what was that?
Yeah, correct. As I said, I wasn't thinking of what to me was the vague concept of time that philosophers often debate. In fact, they've been debating about it for thousands of years. I was just focusing on, okay, what can we do in physics? And that led me to the concept that our philosophical construct for time doesn't exist, which was a surprise because I wasn't even trying to evaluate that. I thought maybe this was a mystical thing, a mystical construct, and maybe 1,000 years from now we'd find out more about it. But first I said, oh, here's proper time does all we need in physics, and it's a good physics construct. I thought a little more and said, hey, there's nothing more than that. And then I went a little bit deeper and said, okay, even deeper than proper time is process length.
Right, right. And I think that goes along with what Borkert has said, because when he talks about time, he just says it's movement. And in some sense, I think you're sort of both saying the same thing from different angles,
Right.
where it has to do, if nothing, like you gave us the example of a static universe where nothing's moving. Well, where you don't have time, right? I mean, you don't have a psychological any. You can't even put a psychological or philosophical time on top of it.
Right.
Movement is absolutely intertwined. You cannot have the time. Is does that? Am I getting that correct? Or
Yeah, let me just repeat. When you see, say, a toy car going across the rug, you think of it as time unfolding. That's what you're seeing. But what you're really seeing is a process, namely the car's motor and the wheels turning, unfolding. And that's all
right,
there is to it. We don't need to add this superfluous construct of time. There's no separate thing that's driving something called time. Yeah, all the processes unfold 100% within three-dimensional space.
Mhm. Not four-dimensional? Not kidding. Oh, but you said something. I wrote something down here. We'll get to questions. So if you have questions for Nick, please put them in the chat. Also, we'll be going to our green room. So let me know if you want to make a comment or a question. Again, if you're in the green room, we have sort of a rule. We're not wanting to know your idea about something. We're more want to talk about what we're talking about today, because there's a tendency that can happen because we're all excited about what we're thinking. But I have this note here on time dilation. time dilation from what you're saying, I thought was really popped into my mind, for what I can understand. Time dilation requires time to be a separate physical, discernible thing in the universe, really. Because, I mean, that's
Yeah.
the only way, because you don't slow it, because if it's a clock, what we heard in the NPA, they use it a lot, was clock retardation, which I thought was a great phrase, because it talked about this is a clock, it's a physical thing, and that those cycles are slowing down or speeding up. But is that sort of your take, that time dilation, if time is not a separate thing in the universe, that's like this thing that's ticking, like this thing outside the universe ticking, how could there even be time dilation? Am I reading that right from your work?
100%. Yes, 100%. It's
Okay.
just adding a construct that's misleading and sends special relativity down the wrong path. Lorentz, who thought in terms of absolute motion, absolute velocity, and preceded Einstein, and had really developed all the equations of special relativity, except that they were absolute equations, absolute from the point of view of a preferred frame, which was in his mind the ether rest frame. And he used the terminology clock retardation, which is the correct reflects the correct physical view. And it's the term that I use all the time.
Right. I'm sorry, I'm watching the questions and stuff. We have Toby Groth saying, how do I get in touch with Nick? I would like to talk with him offline. I do have your email. I don't know, can they go to twinparadox.net and get a contact from you there, or how does that work?
Yes, you can go to twinparadox.net. That gives all of my ideas. The homepage talks more about the GPS empirical data, but all the other pages look at the logic flaw that results when you examine special relativity and its claim that there will be a net proper time difference in a twin paradox scenario.
Okay, so yeah, I put that up on the screen there, twinparadox.net. You can get a hold of Nick that way. So yeah, and tell me, I guess the same argument you would have with time dilation, which is this time slowing down, it would also apply to general relativity. Sort of saying what Borchert says too. Is that correct? The sort of same idea?
Well,
Do you have a different take on that?
when Einstein developed general relativity, he first developed the gravitational equations, which are real-world physical equations, and they're supported by GPS. GPS confirms that there is asynchronous, quote unquote, time dilation as a function of change in potential energy. But it really isn't time dilation. It really is referring to atomic processes are slowed down as a function, or speeded up as a function of change of gravitational potential.
Right.
So
Now you got this. I mean, you were in real chorus. I'm so sorry we lost Ron
Yes.
not too long
Yeah.
ago. That guy
Yeah.
was such an amazing person, and he was actually in my documentary talking about it. And one of the statements my mom asked him was, "Well, what do you think about space time?" And he said, "You can't. They're disjoint. You can't even put them together in the first place, let alone having something exist like that." And one other thing, what? Tell me, that's a good point of departure. I was very curious. What was it in your discussions with Ron Hatch? What did he bring to you in your work on time over all these years? What was it that your conversations with Ron, for those who don't know, Ron Hatch was one of the premier scientists in GPS history, really. He had over 30 patents in GPS. Made some money off of it, actually retired, and then Deere tractors he told me, I don't know if you know this story. I said, Ron, why'd you come out of retirement? He goes, well, Deere Tractors gave me an offer I couldn't refuse. So he was an absolute, powerhouse in GPS, and he used to talk about it. What was it in his conversations that really explain to the audience? What did you get from those conversations with Ron?
Okay, before meeting Ron, I had figured out from a pure logical point of view that claiming that special relativity's time dilation could explain a difference in proper time between the twin that stayed at home and the twin that went on a round trip, that led to logic flaws, led to contradictions. But then Ron acquainted me with all of the proper time empirical data from GPS, and that confirmed what the logic showed. So it was really opening up in the empirical data.
Yeah, so give us maybe, that's interesting. Can you give us maybe a brief explanation of that, the empirical data showing what, for the person who's more lay person, what does that mean? What did that mean in sort of colloquial terms?
Okay, they have GPS clocks on the Earth, and they're all synchronized so that they keep in sync with one another. But when you send an atomic clock up in a satellite, the main two effects are that it will have increased velocity with respect to the Earth's inertial frame. So they take the center of the Earth, which simply moves with the orbit but doesn't rotate, and call that the base inertial frame. So the satellite's more rapid revolution around the Earth increases its absolute velocity with respect to the ECI frame. So that increase in velocity slows the atomic clock that's in the satellite more than it slows the atomic clock that's on Earth. Plus, since it's at a higher higher
altitude.
Altitude.
Yeah, I'm sorry. Hey,
listen, it increases the gravitational potential, which also increases the speed of the clock. And there's a net effect of those two, even though they're opposite effects. So that's how, and that's, so GPS keeps track of the proper time of the clocks on Earth and the proper time of the clocks on in the satellites, and it actually physically adjusts the proper time rate in the satellites so that it's reading at the same rate as the clocks on the Earth. Now that showed two things. One, special relativity talks about relative simultaneity as being an essential result of the theory, whereas GPS, a working system to extremely high precision, implemented absolute simultaneity within the vicinity of the Earth. And the other thing it showed is that special relativity's time dilation is at odds with the proper time data from GPS.
Yeah,
particularly regarding absolute velocity. The change that general relativity predicts from those original gravitational equations is in sync with the data. But then to go from those initial equations to general relativity itself, they broadened it and they pasted on a lot of special relativity, which was incorrect.
Right, right. I know in my movie, I asked Ron. I said, Ron, can you give me a one sentence statement, which I put up sort of like during the a documentary. You put sort of a statement right on the screen, big,
Yeah.
about relativity, and he said, you know, when you're always looking, oh, will it prove it wrong? Of course, you know that's. He says, look, that's. Let me give you my statement. And the statement he made, if you guys see the film too, it's available online. He said that a GPS doesn't support relativity; it actually shows the flaws in relativity. I don't know if you talked with him in his in his life, but he was communicating with NASA about something very interesting because NASA was having a problem trying to explain what the a point I don't know 0.56 pico seconds difference. Of course, you know, with Ron, picoseconds are an eternity
Yeah.
of psychological time.
Yeah.
And he was with the idea, and I don't think it ever got to fruition because you know he died before that. But I mean, he could get to really a conclusion. But he was trying. He was telling me that he thought that perhaps what was happening, that the speed of light, that change, if you added in the speed between the satellites and the speed of light, that in fact that correction would go away, and of course that flies fully in the face of the idea that the speed of light is a constant. And he said, well, one of the problems they have in physics is they could never explain, well, when the light goes one way, it's c plus v, and the light goes the other one, it's c minus v, but it averages to c, so there's no violation. But I mean, it's really what in your work, the speed of light, is that something you really looked at as a constant or variable? I think most people today say it's more of a, how do you say, what we measure, but it's not an absolute constant. Is there anything in your work that like that, or that's you've talked about the speed of light constant or not, or is that just not something you really thought about much?
Yeah, I haven't looked into that personally myself, but in talking with Ron, I remember his saying that because uh, of the communication between the satellite and the receiver, it showed
Right.
that the speed of light is not constant.
Yeah, right, right. And that's, you know, that's not surprising, really. I think, you know,
Yeah.
we measure things, but it's surprising to other people. Okay, I'm gonna let's see. We're at 11:30. That's when I usually try to open up
Yeah.
the green room. So, if somebody would like to come up and say, and again, sort of the rules is we don't want, you know, if you have a short explanation of something you think is interesting to talk about, that's great. If you want to make any comments or have any questions, that's better. That's what we're looking for. So anybody in the green room, just raise, you know, I have some questions actually from the green room. So let me get to those. We have a private chat in the green room. Okay. Um, here are two. This is from DP Allen. How does proper time explain the ability of GPS to synchronize cesium clocks throughout the inner planets?
Well, I haven't looked at that, but it synchronizes time on Earth, and I imagine they just use it the same way. They look at it purely from a proper time point of view and purely from the processes that drive the atomic clocks. Like on Earth, they take into account the two major effects, namely the absolute velocity with respect to the local preferred frame, which in the vicinity of the Earth is the easy I frame, and difference in gravitational potential. So that's the way they would do it for the inner planets, the same methodology. They look at the process and they look at the physics of what would affect the process driving the atomic clock, and they can adjust the atomic clock or just for any differences in the atomic clock that way. as I've said before, that you could take the basic methodology the GPS uses today in the vicinity of the Earth and extend it to the entire universe. There were a lot of pragmatic problems, and you'd have to know the physics of every inch of the universe to get it to actually do it. But theoretically, it could be done.
Right. Okay. Okay. Hope that answers your question. I'm going to go to another question in the private chat because we're getting some direct questions. There's a lot of chatter going on in our comments area, and that's great. People talking amongst themselves. It's a stimulating presentation, and that's totally fine as well. Another question we have from James Keene. How does Nick explain atomic clock rate change as a function of gravitational potential?
Okay, again, that's not one that I looked at, but let me make some comments that might be a catalyst to your thinking on that area. The way Ron thought of it was looking at clock slowing as a function of absolute velocity, which would also mean clock slowing is a function of absolute kinetic energy, and the effect of decreasing in potential gravitational energy, and tried to think of it in terms of energy. And he did that by thinking about the whole thing in terms of energy. And the problem was that as kinetic energy increases, a clock slow, but as potential energy, gravitational potential energy increases, clock speed up. So while he thought of it in terms of energy, he kind of had to add what I would consider as a fudge factor by saying that the internal energy of the cesium atoms would vary to compensate for those two different opposite effects. Now, the way I think of it is I think of the gravitational field as really defining the preferred frame in its motion with respect to the gravitational field that simulates an increase in gravitational potential or decrease in gravitational potential. So that's just the two different opposite effects are just the flip side of each other, and it's really the same effect. It's the effect of the gravitational field on the cesium atom.
Okay, all right, thank you. And I've got another question. This one.
By the way, I'm probably the only person in the world who thinks of it that way, James. That's not an accepted view, nor was that Ron's view accepted. So it's one that we'll have to puzzle.
Well, I consider you an expert. Thinking 50 years on time. We get into the idea of what's an expert, who's an expert isn't. I think we get into trouble. It's mostly of what people are saying that really is stimulating, makes sense. Like you said, it makes your brain go in new and different directions.
Yeah.
So I got a question actually from the live chat here. It says, Nick Percival, wouldn't it cut straight to the case if you just credited forces as the property that animates the world's processes?
Well, I don't know if it's forces or energy, and I know you and Borchardt have a different view than I on energy, but it seems that you have mass, and we kind of agree on motion as an essential aspect of physical reality.
Right.
But at this point in my exploration, and it's always evolving, it seems like there must be something that drives that motion, that animates matter. And I don't know if the more perceptive view is it's energy or forces or something else.
Yeah, I mean, the way I would look at it is this just movement? Movement's there. If you try to figure out why it's there, is different. And I think energy, and the way I would, a lot of us think of it, is sort of a concept, much like the capital T time is. I mean, it's a very nice concept. It's something that we think, there's so much energy in something. It's very useful. But the thing of like, give me five energies in my hand. Well, I think what you're saying is that there is the movement is caused by something. And then if you
Yes.
believe in an
Yes.
infinite universe, then it's caused by things below it and above it and everything around it. But the moment, I guess the way I would look at it from my point of view, and other people who share that kind of idea that energy is a concept, is like energy is really the big E energy in your kind of notation, is that you're not going to explain where it comes from. There's always, it's going to be from somewhere else of something moving. If it's infinitely down or infinitely around you, then that's where it's coming from. But to explain where it originated, like who was the first thing to push in the universe, I think movement's there and always will be, and it's one of those things that's like an assumption. And I think I don't see any real conflict in that
Mhm.
idea from what you're saying. It's just a
Right.
different way. I think you're using it some sense in our mind, taking your analogy that you're using the psychological, philosophical energy, whereas what we're saying is its movements is always there at all levels, and the universe doesn't exist without the movement. And to say where that comes from, you'd have to know everything moving at every place, and that's like you said, it's an impossibility. It's like you were talking about this, the clock. Yeah, I mean, if you knew the entire universe, then you get your answer.
Right.
So, okay. All right. Anybody in the green room? Let me see if people were waving their hands. Okay, I do see Ian. Hello, Ian. How are you?
Hello, David. Very well. Hello, Nick.
Hi, Ian.
Thank you. Good to connect again.
Yeah.
Quite a number of years ago, actually, I first came across Nick through the Glenn Baxter sessions we used to have many years ago. I think I gave a presentation about 8 years ago, and you all responded quite
Yeah.
interestingly on it. But I've just an observation and then maybe a question following on somewhat from those earlier questions about the atomic clocks, which Nick may care to comment on. The observation first is merely to say that treating time to be analogous in some ways to spatial dimensions, didn't come in with special relativity or Minkowski. It predates that because, like in the say D'Alembertian type analysis, the French mathematician D'Alembert, if you substitute a value tau, say, which is ICT. We have the square root of -1 times the speed of light, if you're taking radiation, times time. Well, then that behaves in the same way as a spatial dimension in getting the wave equation, or in getting the sort of Pythagorean dimension, of a ray just going out. So that's merely an observation which you may care to comment on. The other point is, we've sort of touched on this before, I think many years ago, perhaps, Nick. But I take these explanations for the variation of an atomic clock relative, let's say, to the ECI frame of the Earth. So it's sort of an absolute thing. Dependent upon the speed of the atomic clock, and also its gravitational potential. I do take that, and you can talk in terms of energy and so on. But it does seem rather strange that the figures come out congruently with what would be predicted for time dilation, which we reject, of special relativity, or, if you like, retardation of Lorentzian relativity, and also the gravitational potential of general relativity, the time not dilation but contraction. So it's funny, it's a bit of a coincidence there, I maintain, Nick.
No, not a coincidence. Well, first, when you talk about tau, that really represents proper time. And as I say, you don't have to rewrite every single physics equation just as you don't have to change all of our casual conversation. But you have to realize that in the example that you gave, tau is not representing anything like time. What it's representing is the process of that wave propagating. And that's, so you don't have to understand that if you just want a particular numerical answer or you're confined to that process. But if you're building a physical model, you better understand what's underlying tau. Otherwise, you can come up with special relativity. Now, let me talk about special relativity. What Lorentz first developed all of the equations of special relativity prior to Einstein, but velocity was absolute velocity with respect to the preferred frame, which in his mind was the ether. What Einstein did was have each inertial observer simulate his being in the single unique preferred frame. And special relativity gives the wrong answer for anything involving proper time, which is an absolute observer independent thing, a quantity, for generally speaking, for everything. The only time it will be correct is if that false assumption that all inertial observers are in the single preferred frame, which obviously is self-contradictory, if it happens to be that the observer is in or near to being in the single preferred frame, which in the vicinity of the Earth is the ECI frame. So if you, like special relativity, claim that, hey, I could have chosen any other inertial frame and given the right answer, if GPS had done that and taken any other frame than the ECI frame, and they'd be wrong. And the more that the inertial frame differs from the GCI frame, the more people would be guided into the ocean and lakes and trees and whatnot. Is that a good answer?
Yes, it is, Nick. But just getting in a little more to the sort of coincidence that something that consider as erroneous gives the same values, for
only in special situations. There are two special situations where it gives the correct values. One, for everything that's Lorentz invariant. And it wasn't a coincidence. Lorentz got it right. And then Einstein made an adjustment, made it wrong. But it has the same equations, except in one case, v is absolute velocity. And in Einstein's case, it's relative velocity with respect to any inertial observer, which would cause anybody to question the correctness of it being representing physical reality. And often, empirical data that disproves special relativity is interpreted as supporting it because they don't recognize that they're using absolute velocity. And if they tried to apply that equation as special relativity applies it, they prove themselves wrong.
Well, just one more point. You probably agree, do you, Nick, that other types of clocks would not necessarily experience the same dilation or contraction. So I maintain that this is a property of atomic clocks. And, Lorentz wasn't dealing with the type of clock. He was making a general statement about time, albeit it was an absolute relative to the ether.
Well, Lorentz called it clock retardation, but he applied it to waves. So almost he's applying it to any atomic phenomenon. Poincaré came in and introduced the phrase local time to represent someone who wasn't at rest in the ether frame. But Lorentz, I think, well, he certainly wasn't thinking in terms of time dilation, because he had one model, and that was the model that you develop using his equations, and velocity is velocity with respect to the ether rest frame.
Okay. Thank you very much, Nick.
Yeah.
Thank you, David.
But he admitted that, you know, if someone is in another frame, then there will be this distortion to their observations due to the fact that they're traveling with respect to the ether rest frame, and that introduced some atomic effects, namely the electromagnetic interaction between the atoms in the moving object and with the ether. That's how he explained it, and he used the work of Heaviside to work out his Lorentz transformation.
Okay. And we have other people in the green room. Anybody else want to come on, make a comment, or just let me know? I know there's a lot of questions about the cesium clocks. I think people are fascinated by just time in. I think I've got. Mr. Allen wants to come up here, but I'm going to ask you a question ahead of that. When you've been studying time, and yes, there's a psychological time, but we also have a fixation on measuring time. And how do you see a person, what I call one of the foremost experts in time on the planet, how would you categorize that? Our fascination with measuring it, what it causes psychological, it's a sort of a big question. But I see that there's that curiosity constantly. Well, you have the hourglass in space, doesn't work so well. You have a pendulum clock here on Earth, works great, and space doesn't work so well. Then we have the cesium clock, and we're always very fascinated about measuring it. What do you see as a person who's thought about this? What can you give your perspective on the actual measuring and our fascination or fixation on that?
Okay, trying to measure time is trying to measure a fantasy that doesn't exist. In all cases, what you are doing is using a particular process to give you data. And the empirical data is just is measured in the inherent characteristics of the process. So there's no general time. We don't move in time. We move only in space. And it's powered by energy. In fact, the equations of time in physics and the equations of energy have the same canonical form. So, and that's because when they're thinking about time and looking at it and trying to develop equations, what they come out with is the equations for time, energy.
Okay, I'm going to bring up Mr. Allen here. Mr. Allen, here you are. How are you?
Can you hear me? Last time you couldn't hear me.
We can hear you fine and dandy right now.
Okay.
Hi, Dennis.
Hi, Nick. Good presentation. Andre Michel, the new editor of the General Science Journal, has 2 books out, which you can get on Amazon. And he sent a message on ResearchGate. He's on ResearchGate. I don't know if it was for me or for someone else. We were all messaging each other. And he said that his theory, which doesn't involve conservation of energy or momentum, can't explain the fact that the cesium clocks speed up or slow down depending on 2 factors, namely the gravitational potential and also the absolute velocity relative to the fixed stars.
Okay. Well, as I say, I don't know what he's really thinking, but Dennis tried that from a pure energy perspective. And I didn't see him overcoming the contradiction that as kinetic energy increases, clocks slow. but as potential energy increases, clocks speed up. So it's hard to explain the whole thing in terms of energy.
Well, he doesn't believe in conservation of energy. Andre doesn't. I just wrote down equations. I had no idea why they held, just that they were empirically apparently correct. But Andre is heavily into particle physics, and his two books, although they're expensive, are well worth the price, I think.
Yeah.
He has his quantum mechanical theory, not involving conservation of energy or momentum, and he claims he can explain all that.
Well, yeah, just from what you said, you can't explain the fact that, one increase of energy causes the clock to speed up, and another increase in energy causes it to slow down. I mean,
he doesn't go with conservation of energy. That's not his bag.
It's not a case that can't explain it. I've looked at Ron's. I know it pretty well, that area, because I looked at Ron's, and he had to introduce some magic to try and get it explained.
I know. Well, his work inspired that work that you mentioned of mine, gravitational inertial mass, which you find on ResearchGate. Yeah. But I didn't, since I'm not a physicist, a mathematician, I didn't attempt to explain why it happened, just that it did happen and what were the consequences. David and his father have their theory, and they claim to explain things like charge and mass and so on. Maybe not mass, charge. And I don't explain it, but rather I try to write down equations that are correct involving that.
Right, and if you get the correct equation, that's certainly helpful, but then you have to make the next step as well and provide the correct physical interpretation. And there are always multiple possible physical explanations or interpretations of an equation.
Yes, that's right. But you do have to get the right answer for an engineer in the field, for example.
Right.
You can know all the theory you want, like Cynthia Whitney, and she tried out special relativity theory on ring gyros, and it didn't work. That's why I feel like let's get the answer right first, and then we'll figure out why it's right.
Right. I agree.
Okay, thank you very much, Alan. Which it's really true, of course. I think one of the really strange things people. I mean, my father and I never ever thought about making a model of the universe until my dad came up with an idea, and I looked at all the things that I had collected over the years. I mean, it's an attempt, right? But it's really interesting that people come up to you, because now that we do have a model and we've been working on it for 5 years, they go, well, you have to explain this. You can't just ignore this. And I think to myself, do people think, I wonder, do people think we're like really dumb that we sort of, my dad and I go into a cave somewhere and we throw out all of science, all of engineering, all experiments that exist, and we just then build a world like Harry Potter with all our own rules? I think somehow people don't think that when people think about something like you have for so long, that have you thought about this? I know has nothing to do with what Mr. Allen said. This is, he had some very astute comments for sure, but it really is interesting. And Allen, he said, Mr. Allen said, you have to explain something. If you don't have charge, you have to explain why what is called the electron is going around, a neutron, or you have to explain, how an electronic circuit works. I mean, you have to, and people, I think, expect us to say, oh no, we don't, we just do what we want and ignore all of physics has come before us. So I mean, it is you've during your time with time, you have really run across quite a few people, quite a few ideas, and some of them have affected you more than others. Some have supported you, but I think a lot of it really has to do with vocabulary. That's what I found because I got a master's in linguistics, and I always look at what does a person mean. And I think a lot of times people use words, unfortunately, way more haphazardly than they realize. They turn into this physics, what I talked about, and we had a whole session on that, which is physics poetry. And I think how much of the problems do you see with time that really have to do with this problem of us with the capital T time you talk about? I mean, time is flowing like a river. It's like Pink Floyd, I think, is the famous song, right?
Uh,
And how much do you think that in physics we get thrown by our psychological thoughts of what these things mean versus what you say time is? There's the time, which is really the measurement of processes that's related to processes that go on, versus the psychological. How much have you seen, even in your own work, how that gets in the way of really trying to find out what time is all about? Because that gets in the way quite a bit.
I agree 100%. And of course, that was a hot button of Greg Volk's about making sure you both have the same definition of a word when you're arguing about that, the effects of that phenomenon. With special relativity, that was, I believe, a really major effect of going way down the wrong road. But Newton had, had philosophical time and psychological time, although he called it absolute time. But he thought it had its own separate identity, and that led him to have sort of a view that the entire future is defined. If you had enough information, you could figure out everything. But you talked about, you were surprised that you ended up having a model of everything. I just started with time, and I ended up thinking time doesn't exist. That was a surprise.
Yeah, no, it's really amazing the journeys we go on.
Yeah.
Yeah. I'm gonna stop us here. This has been really, really fascinating. I mean, I've got lots and lots of comments from people who really have enjoyed this. I want to thank you for coming on. My earphones are out, so I'm having to play the mute game so we don't get feedback. But I want to thank you for taking the time. I'm sorry, I had to say it.
Yeah,
For
I can't. I have to do the same. Can't get rid of it.
Yeah, and so I want to really thank you for your time and also for your YouTube channel. And make sure you check out his YouTube channel, Nick of Time on YouTube. Look it up, Nick Percival, Nick of Time. Subscribe to his channel. He's got a lot of great thought-provoking talks on time. And we hope to have you back when the next, how do you say, process comes along that makes you I don't know what's left. If you started 50 years ago searching for time and now you say it's not real, what's left? You've eliminated it completely. Maybe tell us about what you're currently working on before we head off here today.
Well, in terms of replacement, as I say, we have matter and matter moves, and to me, I'm at the point of saying, well, we got to have energy or a force or something like that. So regarding this topic, I don't have that much plan for the future, but I'm going to look at quantum mechanics. With certain aspects of it seem like there's, as you say, science poetry in it, and some psychological constructs and fantasy concepts.
Okay, well, listen, Bob and Ann, I don't know if there are really two people, so people can put what they want there, but they say they loved it and they will be back next week. So,
Yeah.
thank you so much again, Nick, for your presentation and all your work throughout the years and your support of this organization. It's quite important. All of those things, and I absolutely admire you for taking on this task. Where when I contact you, says, "Hey, you should start a YouTube channel," and you were in your late 70s, early 80s, and you're probably thinking, "What's this guy?" But I think it's paying off, and people are listening now. I think we're starting to see some cracks in the of mainstream physics. So thank you so much.
Yeah, thank you for bringing us into the 20th century with the computer and the internet, and then bringing us into the 21st century by using social media. It's tremendous.
It
Great
really
stuff.
is. It really
Yeah.
is. We have so many people that are new. So thank you very much. Again, thank you everybody who is attending, and we're going to go get our way out here. I know we're over a little bit of things, but let's get ourselves on our way out and show you a few quick videos here about our organization. And of course, coming next week, we have Ray Gallucci, who's going to be talking about gravity and the electric universe. People who believe that gravity is not the major force in the universe, who believe it's electrical. That's going to be truly fascinating. We're going to watch one of his presentations and talk about it. So all you people who are in the electric universe, come our way. Love to talk to you. Hey, if you're in the electric universe and know, I've talked with Wal Thornhill. Maybe I'll give him a ring and have him come on and talk about his work. I really admire the electrical universe, and because why? Because they're creating critical thinkers, and that's really important. And as I always say, stay critical, stay thinking. I am David D. Hilster, your science therapist, trying to get you to the promised land of becoming a critical thinker. We're not here to tell you the truth. We're here to show you critical thinking and the freedom of thought so we can move science forward, because it's awfully stuck. I think if you take the time to look at it, you agree with me. Ciao for now.